Okay, welcome to the class, and we have been discussing SRS in all its detail, and we'll continue discussing that. Okay, and so where were we? We were looking at this SRS and the frequency hopping in it. Okay, so the reason for frequency hopping, as we understood, is that UE has a limited transmit power. Okay, and transmitting SRS over a large bandwidth part will reduce the SRS power density, okay, and lead to poor channel estimates. And what standard does it basically allows the UE to hop the SRS from one frequency to another. That's what is happening, okay, to increase the link budget or to increase the SRS power density. Okay, because same power is now allocated to fewer number of PRBs if hopping is enabled. Fine, okay, right? So that's what we do, and so basically configure the SRS over a smaller bandwidth and then hop. But now this needs to be enabled. We understand that the hopping can be done. Okay, so in the same table there are those different columns: BSRS 0, 1, 2, 3. So all that is used to enable hopping. Okay, and that's why I'm digressing and teaching you this idea of hopping. Okay, when applied to SRS. Okay, similarly there are other kind of hoppings enabled by the standard. Okay, the last example was intra-slot hopping, wherein the SRS was hopping within a slot. Look at this now. Okay, so we are considering two different slots, slot n and slot n plus 1. Okay, right, and what we are saying here is that inter-slot hopping, if we look at this, okay, what is happening here, there is something different than what we saw last time. Okay, and first thing is this inter-slot hopping. Okay, right, the hopping is basically happening across slots. Okay, this is not hopping. Okay, this is given a different term, this is given a different name. Okay, and this is called repetition. Okay, right, the base station realized, okay, even doing this hopping what we did last time here, okay, is leading to lower SRS power density. Okay, and still the channel estimates were poor. Fine, okay, because UE is in deep trench. Okay, right, so transfer power, transfer signal gets attenuated a lot. Okay, so base station knows that. Okay, so what it does is as follows. Okay, so it says, okay, the UE is not moving fast, UE is stationary. Okay, and so channel across the slots remain more or less constant. Okay, so what it does is that it sounds out only this part of the bandwidth in one slot and this part of the bandwidth in another slot, not in the same slot. Okay, but within that slot, what it is allowing, it's allowing repetition. Okay, you see this. This is, what am I writing? Inter-slot hopping with 2-time repetition for a 2 OFDM symbol SRS resource. We said, right, OFDM, this SRS can go from 1, 2 and 4 symbols. Correct? That repetition we were talking about. So this is that repetition. Okay, repetition, what will again happen? We discussed this yesterday. Whenever we are repeating a signal, you can again increase the SNR by a factor of 3 dB, right? Okay, so first 3 dB you have gotten by only sounding out this part of the bandwidth, not the complete bandwidth part. Second 3 dB you are getting by repeating the SRS. Fine, this we understand why this repetition is being done. Okay, so you get basically 6 dB of increased SNR, right? Okay, 3 dB by SNR reduction, 3 dB by transmit power boosting per PRP, because same 250 milliwatt is allocated. Okay, this is basically will help you in the noise averaging. We understand that whenever we repeat a signal, we get 3 dB of SNR improvement. So that this is that. Fine. Okay, so what are we saying here? Only half of the SRS bandwidth is sounded in each slot, different from the last case. Power density is increased by 3 dB compared to a full bandwidth sounding. This we understand, that's what we have said also. Okay, use of repetition, which again increases the power density by an additional 3 dB. To be very precise, is the SNR which gets increased by a factor of 3 dB. So you get 6 dB boost, right? Okay, And why is all this being done? Because the channel estimation is very important information for any receiver to have. If the channel estimates are bad, the rest of the receiver chain suffers. Okay, so you need to see this, how much of focus is being put on getting good channel estimates, right? Okay, so what does this repetition do? It is clear, but we are writing it for the record. Repetition allows same set of subcarrier to be sounded in R consecutive OFDM symbol before next hop occurs. This is a technical definition of repetition in the standard. Okay, what are we saying here? Allows same set of subcarriers to be sounded out in R consecutive symbols. R is 2 here. If R is 4, that can also be done. Correct? The UE condition is like worse than this. Okay, so it will sound out in, it will allow repetition, base station will allow repetition of 4. Right? So that's what is happening. So it's another kind of hopping, and this hopping is inter-slot hopping with the repetition of 2. Okay? Right? Earlier case was intra-slot hopping with no repetition. Correct? And there could be no hopping at all. Right? If the UE channel is good. Okay? Right? So different configuration, and I'll teach you how that is enabled. Okay? There's one more. Okay? Another hopping configuration. So allowed value of R are 1, 2 and 4. This is 2. 4 could also happen. Okay, that's how SRS is designed. We saw that, right? Okay, it's coming over 4 consecutive symbols, 4 consecutive, 2 consecutive symbols. Right? So all this is neatly coupled together. Okay. Now intra and inter slot coupled together. Okay. So you see this here. This another different example of SRS hopping. That's all. Okay. So what are we saying here? Hopping is happening. There is no repetition. First thing you notice, there is no repetition. Okay. So what is happening here? Intra and inter slot hopping for a 2 OFDM symbol SRS. Okay. This symbol, this SRS is spread over 2 OFDM symbols. Okay. Here between this part of the bandwidth part and this part of the bandwidth, this is intra slot hopping. Correct? Okay. And this is also intra slot, but the full bandwidth part is being sounded using intra slot hopping and inter slot hopping. That's what is being said. Understood? Okay. This is intra slot hopping. This is also intra slot hopping, but together it is intra and inter slot hopping. So that's how the complete bandwidth part is being sounded out. Okay. Or whatever, like if it is only a part of the bandwidth part also, you don't care. Okay. But this is being sounded out. Fine. Okay. So in each symbol you see this, only quarter of the SRS bandwidth is sounded. So 6 dB increment. Right. Same 250 milliwatt of power is being used only for this. Same 250 milliwatt of power is used only for this. Again, straight away 6 dB of SRS power budget gets increased. Right. So these are the different ideas of using the SRS hopping. Okay. And what is happening in this case? So it takes 2 slots to sound the whole SRS bandwidth. Correct? 2 slots are used. Last case also 2 slots were used. Case 1 only 1 slot was used. Okay? Right? So power density in this case also gets increased by 6 dB compared to full bandwidth sounding. If whole of this SRS sent here, right, that will be poorer by 6 dB when compared with this configuration. Right? Okay. So this is the idea of sounding with hopping. Okay. And as I said, it could happen without hopping also. So all these options should be configurable using the table which I showed you. That's the problem we have at hand, and that's how it is, this configuration table is designed. Okay. That's what we are going to study. I gave you a brief overview of how this SRS configurations are done. Right. We'll continue discussing that. Okay. We have to digress to tell you this because otherwise it's difficult to understand or appreciate the notion of SRS hopping. Okay. So basically it is done to improve the channel estimates. Okay. Fine. So we come back to this figure again, right? Okay. So what are we saying here? Okay, we started with this figure, correct? And we looked at only some of these parameters. Okay. right? So this was MSRS 0, it has become smaller here, okay, but this is MSRS 0, right? Okay. So what's happening? MSRS 0 determines the maximum bandwidth within the bandwidth part that can be sounded out by SRS, and this is that MSRS 0, right? Okay. This is the first parameter we need to keep in mind. Okay. What is this N shift? N shift is the index of first PRB of maximum sounded bandwidth, right? Okay. If I am telling that UE needs to send SRS only in this, so N shift will indicate from where to begin sending the SRS. We have discussed that. Okay. Now this is a new parameter. Okay. What is this new parameter? This is telling us that this parameter B hop determines the actual sounding bandwidth. What is this actual sounding bandwidth? You want to sound out this complete bandwidth, that's what we are saying. What is this actual? Actual is basically you have to go back and recall this notion of hopping. Okay. In each hop, how much bandwidth are you sounding out? Okay. Right? Understand this. Okay. When you are interested in sounding out the complete bandwidth. Okay. Right? This parameter B hop determines the actual sounding bandwidth. This also we'll see. Okay. So what is this actual sounding bandwidth? In each hop, how much bandwidth you are going to sound. Okay. So if in one hop itself you want to sound out the complete bandwidth, what happens? There will not be any hopping. Right? If the actual sounding bandwidth is equal to the maximum sounding bandwidth, there will not be any hopping. Right? Because what is this? See, that's how it is defined, B hop. Okay, right? So it will actually determine the hops. Okay, right? So this parameter B hop determines the actual sounding bandwidth. Okay, as how? This number will be given, B is equal to B hop. Okay, we substitute it over here. Okay, so this number B can take values 0, 1, 2 and 3. So what am I saying? You have to read these together, this and this together. Okay. Now, if B is equal to B hop can take value 0, 1, 2 and 3, right? Okay. So if I set B hop as 0, fine. Okay. So what will happen here? My actual sounding bandwidth, what will it become? MSRS 0. There will not be any hopping because actual sounding bandwidth is same as maximum sounding bandwidth, right? So you have to be careful in reading this. Okay. That's how the standard is more about reading carefully. Right? Okay. So if B is equal to B hop is 0, your actual sounding bandwidth is equal to the maximum sounding bandwidth. If B hop is 1, what will happen? Your MSRS becomes 1. Look at this. Right? So what happens? Your actual sounding bandwidth becomes 24, but your maximum sounding bandwidth is 48. So you will need 2 hops. That's all. Right? So I can, if I set B hop as 3, my actual sounding bandwidth is 4, my maximum sounding bandwidth is 48. So I am basically only sounding out 1/12 of a bandwidth, actual sounding bandwidth in each hop. That's why these different tables are there. Okay? Right? Understand? Okay. So let's take an example again, okay, and then it will become more clear what are we saying here. Okay. So let's look at that. So I have taken an example. Okay. So what are we saying here? So look at this. The size of the bandwidth part is 106 PRBs. Okay. There is a system for which the bandwidth part is configured to be 106 PRBs. Okay. Fine. Right. Now, but the base station is only interested in finding out the channel in only a part of the bandwidth part. And how much is that? 48 PRBs. Correct? Look at this. Right? Base station is not interested in finding out the channel here, neither here nor here. Fine? Okay. So how will it, first thing it needs to pick is CSRS. How will it pick? It will pick it to be, CSRS will be 13 because it is interested in finding out 48 in the 48 PRBs. It has to indicate N shift also, right? Which part of the bandwidth needs to be sounded out? That is the offset. Are things falling in place, right? Okay. So this is the first part. So base station has decided that it needs to be, the maximum sounding bandwidth is 48 PRBs, okay, and it has picked SRS accordingly, which is 13, right? Now it needs to decide whether this bandwidth part should be sounded without hopping or with hopping, and if with hopping, in how many hops, right? Okay, that's the next, correct? Okay, so that's what we are going to see now. Okay, so maximum sounding bandwidth is 48 PRBs, that's indicated using MSRS 0, right? Okay, within the 106 PRBs. And how is this MSRS 0 decided? Using CSRS. That's how it has picked this CSRS as 13. Otherwise, it would have picked some other CSRS, right? Okay, so it has picked that. Fine. Okay. Shift parameter is configured as n shift is equal to 24. It is interested only in move from 24, not before that. So n shift is configured as 24. That's all. The offset needs to be defined. Fine. Okay. Let's move on. So the max, what does this n shift indicate? Maximum sounding bandwidth is located starting at PRB index 24. This part is done. UE knows where to transmit the SRS. It still doesn't know how many hops to use, correct? And which parameter is going to decide that? B hop. So B hop needs to be defined, correct? Okay, so that's what we will see. Okay, now in between this, okay, I still need to define, okay, so that basically I've shown you this, okay, I'm still not told how many symbols SRS this is, okay. This is, so what are we saying here, that this is a 4 symbol SRS, okay, and the transmission COM spacing is configured at KTC is equal to 4. What is this? COM spacing, right? Okay, difference between the, is a COM, that's what we said, okay, and what are we saying? This KTC is 4 between two brushes of the COM, okay, right? It is 4, okay, and this offset is configured as K bar TC. It's not shown here, it's hidden behind there, it's 0. This offset is, so what are we saying here? I can use this offset, use this COM, or I can use this COM, or I can use this COM, or I can use this COM. This, the offset here is 0. If 1, then it will be this, right? That's what I'm saying. So how many such offset will be possible? 4 different offsets will be possible. 0, 1, 2, and 3. Correct? Okay, so here the simple case, COM spacing is 4 and the offset is 0, right? Because you are beginning from 0. If the offset is 1, you will begin from here. And then this will come here, this will come here, that's all. Okay, fine. And the starting symbol of the SRS is configured such that the last OFDM symbols in the slots are used. Last 4 symbols. That also needs to be told. Okay, right. Now, so this is, these 2 bullets were about how this SRS is configured. Okay, this COM structure, how SRS COM structure is configured, correct? Okay. Now what are we saying after this? We are coming back to this, whether this bandwidth, complete bandwidth, need to be sounded out in 0 hop or multiple hops. That's what we are looking at, okay. So what are we saying? Look at this. So the relationship between B SRS, which is coming here, okay, and B hop, okay, B hop can take values from 0 to 3. Okay, will determine whether frequency hopping is enabled or disabled. Let's take an example. Okay, I think it will come later, but okay, it's coming here only. So what are we saying here? This is the bullet. Okay, what are we saying here? That if the hopping is enabled, if B hop is less than B SRS. B hop is a number which varies between 0 to 3, right? Okay, and B SRS, I have to pick one of this column. Okay. And what am I saying here? Here, okay, if I set B SRS to 0, okay, and B hop to 0, right? What will happen? B hop is 0, B SRS is 0. What is happening? Hopping will get disabled, right? Because what is happening? Maximum bandwidth is 48, right? And I have chosen B SRS as 0, okay, and I am setting B hop also as 0, right? Okay, what will happen? The whole of this bandwidth will get sounded out in only in 1 hop. right? Because this is if B hop is set to 0, what happens? Okay, this will get sounded, the sounding bandwidth will be, the actual sounding bandwidth will be 48 PRPs, okay, and this is the maximum PRP, right? Okay, so let's continue discussing this. I'll take few examples to further elaborate on that, okay. So is a continuation of whatever we discussed in the last slide, okay. So what are we saying? The sounding bandwidth is 48 PRPs, okay. So this is 3 examples of periodic SRS transmission, okay. So those 3 different transmissions which we discussed in the beginning, okay. So now its hopping cycle is such that it is intra-slot hopping. You look at all 3 examples, okay. This configuration, how it is configured, that will come later, okay. But here the configuration is happening within the slot, the hopping is happening within the slot, okay. Now you see this in all cases, okay, B hop is 0 such that actual sounding bandwidth is 48 PRPs. 1 second, fine, okay. So what am I saying here? In all these cases, okay, I've said that the B hop is set to 0, okay. So the actual this bandwidth which needs to be sounded out is 48, okay, right. Now in case 1, okay, what am I saying here? B SRS is set to 1, okay, right. So what is happening here? Okay, so you see this B SRS, so what did we say? Okay, so that if B hop is less than B SRS, right, okay. So what are we setting over there? B hop as 0, right. For all 3 cases, I am setting out B hop as 0, right. That is the first statement I am making. Now what am I saying here? B SRS I have to set accordingly, okay. So what is this B SRS? Okay. So B hop basically, B hop is set to 0, right, okay. Now in case 1, okay, so this B SRS is set to 1. How many, if you look at this, okay, what are we saying here? In B SRS is 1, how many PRBs will be sounded out in each hop? 24. If I set B SRS as 0, correct, what will happen? That is what I said, okay. If I set B SRS as 0, my B hop is always 0, right. Depending on what column I pick, hopping will be enabled or disabled, correct, okay. Now if I set, the first example is, okay, that if I set B SRS as 0, there will not be any hopping, correct, and the complete bandwidth will be sounded out in 1 hop, right, okay. Here what is this? Look at 3 different configurations, okay. B hop is 0, okay. So here in all 3 cases B hop is 0, let us keep this in mind, okay. What are we saying? In case 1, B SRS is set to 1, right, B hop is 0, B SRS is 1, and I gave you this condition, if B hop is less than B SRS, hopping will be enabled, okay. And how many hops? It is clear. How many hops you will need? Because in each hop, how many PRBs you are sounding out? That is defined in the table, 24. Total is 48, right, so 2 hops, correct. So 24 PRBs will be sounded by transmitting a 2-symbol SRS. That is what is happening. Fine. Now what happens after that? Again, B SRS is 2, right. What is that third column? 12 PRBs. How many hops you will need? Okay, 4 hops. And in each column, you are basically, in each symbol, you are sounding out 1/4 of the bandwidth, correct? Okay, so that is what it is. B SRS is 2, 12 PRBs per hop will be sounded by transmitting a 4-symbol SRS. Okay, because in each symbol, what are you doing? You are sounding only 1/4 of the bandwidth. That is what those tables are telling, right? Okay, and what is happening here? this 1 and 3, these cases, this case and this case with respect to hopping are same. Look at this, okay, right? But what is happening? Here we are using repetition of 2, r is equal to 2, okay. This case and this case are same, okay, other than the fact that there is a repetition factor of 2 over here, right, okay. And what is this? 24 PRBs will be sounded by transmitting a 4 symbol SRS, okay. What are we doing? So bandwidth per hop is 24 PRBs, but you are using 4 symbol SRS, okay. By the reason is we are using a repetition factor of 2, okay. And there is this, the order of repetition and hopping is always, you could say that, okay, I will hop first and then repeat. I could do it like this, right, this and this, then again repetition and do that. But the way it is defined in the standard is SRS will be repeated first and then it will be hopped later, okay. So it makes sense if there is slight change in the channel, okay, right, then over these two symbol variation will be lesser. So correct when compared with the first, this and this symbol, right. So if the channel is constant, then you want to average it, okay. So you want to basically repeat first and then hop it later, that's all, okay, right. So this is the idea of like how hopping gets configured, okay, and the intricate relationship is between B hop and B SRS, right, okay. So if B hop is less than B SRS, it is implicitly clear that the hopping will be enabled. And these are the 3 different examples which we took to reinforce the fact that how hopping gets enabled based on what value of B hop, what value of B SRS gets chosen, okay. It is not over, we have to still discuss this. I will discuss this in the next class, but to summarize, okay, what we are doing here in this class is basically how SRS is defined in the standard, okay, right, and how SRS is configured in the standard, okay. And the reason for giving these different kind of configuration is to enable different UEs in different SNR conditions, okay, to transmit their SRS in such a way that the base station is able to estimate their channel with a good quality, okay, right. And the quality of the channel estimates affect the rest of the transceiver chain, the performance of the rest of the transceiver chain. So it becomes crucial to like send the pilots with a suitable transmit power, and you cannot change the transmit power of the user, the total transmit power, correct, that's fixed, 250 milliwatt. But you can do these kind of contraptions, okay, to enable the channel estimation in a much better way, that's all, okay, that's what we are learning, okay. We will continue discussing this, we will meet in the next class. Thank you.